Okay, so welcome to this exam review. Our first question is going to be, find all the zeros of the function f of x equals 4x cubed minus 20x squared plus 33x minus 18, given that 2 is a 0, and there's just one, I don't know if that, I'm just going to ignore that, I think that wasn't supposed to be there. Write the function as linear factors show all work. So, question is, we know that this is a 0, so how can we find the other zeros? How can we fully factor this? Well, I'm going to use synthetic division. So I'll put 2 here, and I'll put my coefficients. So 4 minus 20, 33, 8, and minus 18. I'll put this little line. And right here I'll put my remainder. So if I'm correct, I should get a 0 here because I know 2 is a 0. And then I'll be left with something that I can try and reduce more. So first thing I'm going to do is we'll bring down the 4. 4 times 2 is 8 minus 12. Minus 12 times 2 is negative 24, which we get 9. And now 9 times 2 is 18, and we get 0. And the reason I did that is when we do synthetic division, it will reduce our power. So I can now rewrite this. This was originally x to the third. So now this is, when we go down 1, we lose 1x. It's now x squared. So we have 4x squared minus 12x plus 9 equals, and we're going to try to figure out where that equals 0. Well, I can go ahead and I can use my quadratic formula. So I'll do my negative b, which is going to be 12 plus or minus square root minus 12 squared minus 4 times 9. Negative b plus or minus square root of b squared minus 4ac. And then it's all over 2a, and our a is 4, so 2 times 4. So 12 plus or minus square root. Minus 12 squared is 144. We can go ahead and we can do this thing. I'm just going to use a calculator because that's a bit big to do in my head. So 4 times 4 times 9, which happens to be 144 as well, over, and that's 8. So we get 12 plus or minus square root of 0, which is just 0. So we're going to get 12 over 8, which is the same thing as divide top and bottom by 4, 3 over 2. So what that tells us is that we only found one root, right? So it means that this thing's going to factor to 3/2. And because we only had one, normally you have 2 factors. Well, it's 3/2 plus or minus 0, which is just 3/2 twice. So that's going to tell us that this is going to go down to, sorry, lost my train of thought there. X minus 3/2 squared. So, going back to this, find all the zeros of the function, and then write the function as linear factors. So we already have one that we knew. We can write this factor as x minus 2, and we have these. And something that we can do to rewrite this, because if I were to square this, I wouldn't get 4x squared. I'm going to move my 2 over to my x. Because now if I plug in 3/2, what will happen is these cancel, so you get 3 minus 3, which goes to 0. So it's the same 0, but now if we were to square this, 2x times 2x will give us that 4x squared. So that's one factor, that's the other factor. So to go back to this, our zeros were 2 and 3/2, and writing as a function of linear factors, we're going to get 2x minus 3. Let me go and erase that, make it a little easier to see. X minus 3 squared. and then we're done. Go on to this next one. Write a polynomial of degree 3 in standard form of zeros, -5, square root of 2, negative square root of 2. So I'm going to put all these as factors. So to make -5 into a factor, it's going to be x, and we're going to switch the signs. So we'll do x plus 5. Next one will be x minus square root of 2. Next one will be x plus square root of 2. So that's it, written as a bunch of different factors, but we need to find the polynomial in standard form. So we're going to multiply this out. So the first time we multiply together, I'll do these two first. So I'm going to kind of write it a little bit down here. X minus square root of 2 times x plus square root of 2. We'll all FOIL it, so we get x squared, outer plus square root of 2, x, inner minus square root of 2, x. Those cancel. And the last is square root of 2 times square root of 2 is just 2. And then we still have the minus. So this whole thing is x squared minus 2. So I can rewrite this as x plus 5 times x squared minus 2. And I'll go and I'll FOIL that as well. So switching colors to make this look a little bit more different. I'll do our first one. So we get x cubed, outer minus 2x, inner plus 5x squared, and last is minus 10x. Rearranging this, we get x cubed plus 5x squared minus 2x minus 10. And that is our final answer. So I'll go in and I'll write this up here. Okay, moving on to the next one. We need to find all the zeros of the polynomial f of x equals x to the 5th plus 3x to the 4th plus 14x to the 3rd plus 42x squared minus 32x minus 96, given that minus 3 and 4i are zeros. Well, one fun fact about anything involving an I, if that's a 0, the conjugate will be, so minus 4i will also be a 0. So what I'm going to do is I'm just going to use synthetic division. I'll do all three of these synthetic division on our polynomial, and it'll reduce it down to something that is going to be more easily able to work with. So I'll do minus 3, 1, 3, 14, 42, minus 32, minus 96. Put my little dotted line. So let's go ahead and start. So we bring down the 1. 1 times minus 3 is minus 3. Add those together. 0. 0 times anything is 0. Add those together, get 14. 14 times minus 3 is minus 42. Add those together is 0. 0 times anything is 0. Minus 32. And then minus 32 times minus 3 is positive 96, and we get 0 there. So that gives us a reduced one, but we know that 4i will also be a 0. So if I try, don't know why I switched to eraser. If I try and do synthetic on now our reduced one, with 4i, it should also work. So I'll bring down the 1. 1 times 4i is 4i. Add those together, we get 4i still. 4i times 4i, I times 4i. 4 times 4 is 16. We get I squared. I squared is negative 1, so we get negative 16. Which gives us minus 2. Minus 2 times 4i is minus 8i. Plus 0 is going to still be minus 8i. And then minus 8i times 4i is minus 32 I squared, which is positive 32. And we get 0. Which that we should have, because it's a 0, we should know that. Now, I'm going to keep going. And this time I'll do minus 4i, because that should also be a 0, if 4i was. So we carry down the 1. 1 times minus 4i is minus 4i. Add those together, you get 0. 0 times anything is 0. Minus 2. And now minus 2 times minus 4i is positive 8i. Add those together, you get 0. So we know that all of these are zeros, but now we've reduced it. So we went from x to the 5th, reduced it once, to x to the 4th, to x to the 3rd, and now we're at x squared. So we have 1x squared, 0 x's, and a minus 2. And we need to figure out when that's 0. which we can now just solve for. So x squared is going to be 2. So x is going to be plus or minus, don't forget the plus or minus, square root of 2. So what are the zeros here? Well, they were minus 3, 4i, minus 4i, square root of 2, and then a negative square root of 2. Okay, so for the second one, we find all the zeros and their multiplies of the functions. First, it wants us to find the possible rational zeros by comparing the possible values with the graph of the function on a calculator, checking the values using synthetic division, or division usually synthetic show all work. Okay, so first, to find the possible rational zeros, we're going to have to figure out what our P and our Q is. Our P is the last thing. Our Q is whatever is in front of the biggest x power, which in this case is 5. So P is 20, Q is 2. Now let's find all of our factors of it. So plus or minus 1 and 20, hope that's well spaced, plus or minus 2, 2, and 10. 3, 20 divided by 3, that doesn't work, so we'll go plus or minus 4 and 5. Barely enough space. And then for 2, it's going to be plus or minus 1, plus or minus 2. So our possible rational zeros is going to be every single P over every single Q. So it's going to be 1 plus or minus 1 over 1. I'll do all my P's over 1, so plus or minus 2, plus or minus 4, plus or minus 5, because everything divided by 1 is itself. We want to do plus and minus 20. And now I'll go ahead and I'll do it over the 2. So we have plus or minus 1 over 2. And then 2 over 2, well, that's 1. We already have that one. 4 over 2, that's 2. We already have that one. We don't have 5 over 2. 10 over 2, that's 5. We already got that. And 10 over 2, that's 10. We already have that. So here are our possible rational zeros. So next we're going to graph it. Unfortunately, I don't think I can show you what my graph's going to look like. But I'm going to graph on my graphing calculator, and I'll try to eyeball and say the zeros that it has, which of these values are close to the ones, just like looking at it. And we'll try to guess based off of those. So I went ahead and graphed it. So what I saw is some good candidates. Were minus 5 over 2. So like I look like about minus 2.5, which is 5 over 2. And then I'll say positive 1. And I'm going to say positive 1 twice. Because when I looked at it, it looked like it might have bounced off of positive 1, which like the graph looks something like. And whenever it bounces off something, that means that you have a multiplicity that's even. And multiplicity even means that your 0 is repeated multiple times. So like 1 might be repeated. So we should go ahead and do these two for sure. But we should check do one two different times. So order check. I'll start off with this one first. I'm going to set up my synthetic division. So I'll put my coefficients 2, 1, and then 0, because I don't have any x cubed terms. Don't want to forget about the 0. That'll throw off your answer. 9 minus 32 and 20. Dotted line. We bring down the 2. 2 times 1 is 2. Add those together, you get 3. 3 times 1 is 3. Add those together, you get 3. 3 times 1 is still 3. 9 plus 3 is 12. 12 times 1 is 12. We get minus 20. Minus 20 times 1 is still minus 20. So we get 0. Okay, so let's go ahead and check the other one that we know we're pretty confident in, which is going to be minus 5 halves. Put my dot line here. So we bring down the 2. 2 times minus 5 over 2. Well, the 2's will cancel. Minus 5 over 2. Those cancel, so we get minus 5. So we get negative 2. Negative 2 times minus 5 over 2. Well, the negatives will cancel, and so will the 2, so we'll get positive 5. which gives us 8. 8 times minus 5 over 2. Well, this 2 can cancel out and make this a 4. 4 times minus 5 is minus 20. So we're going to get a negative 8. Negative 8 times 5 minus 5 over 2. Well, the negatives cancel. And this 2 cancels that out and makes it into a 4. 4 times 5 is positive 20. We get 0. So far so good. Both of those turned out that we thought were zeros. And now let's go ahead and let's check 1 again, because I think 1 might be repeated. So it's worth checking one more time. So 2 times 2 is, 2 times 1 is 2. Add those together, 0. 0 times 1 is 0. Add those together, you get 8. 8 times 1 is 8. Add those together, you get 0. So 1 was a repeated root. So that means that our multiplicity will be at least 2. Now for what we have left, we started out with an x to the 5th, then we went to an x to the 4th, x to the 3rd. So what we have left is now an x squared. So we have 2x squared plus 0x's, then plus 8. So we can figure out what our last two roots are going to be from here. So I'll subtract the 8, divide by 2. Then when I take the square root, plus or minus square root of negative 4, that's going to be the same thing as plus or minus 2, and the square root of negative 1 is I. So it's a plus or minus 2I. So what do we need to do? Well, we need to find possible rational zeros and then find all of their zeros in the multiplicities. So I'll go up here where we're going to answer. I'll go ahead and I'll write them out. So I got, so for my zeros, what I found were, we had 1, we were saying mole for multiplicity. How many times did 1 work? It worked twice, so we'll put 2. We had minus 5 over 2, we only did it once. Then we had positive 2i, also once, and minus 2i, which is also once. And then we're done with that one. Okay, so this one wants us to write a polynomial with degree 3 in standard form with integer coefficients in zeros, 3i, 4, and 4/5. It's degree 3 as well. That might be noteworthy. So we need to figure out what the polynomial is. So we can use a couple of our zeros. So we know that 3i is a 0, so it gives us this part. We also know that if 3i is a 0, negative 3i will also be 0. And now this last one, it's really tempting to write x minus 4/5 for our last part, but here's the thing. Integer coefficients. What that means is we don't want a fraction as one of our involved here. We want this all to just be normal numbers. So what I'm going to do to keep this getting the same 0, but having everything be integers, I'm going to move the 5 over to the x. And I kind of did that on a previous one. I'll explain this a little bit more. So if we have 5x minus 4, if I plug in 4/5 into this, we'll see that the 5's cancel, and then 4 minus 4 is 0. So we're still going to get 0 like we did before, but now there's no fractions involved, and that's just what it's asking for. So we need to put it in standard form, so we've got to multiply all this out. So first, I'll go ahead and we'll do x minus 3i, x plus 3i, x squared plus 3ix minus 3ix, those cancel, minus 9i squared. I squared is negative 1, so this will become x squared plus 9. So I'll go ahead and I'll see that these two become x squared plus 9. And right here we still have 5x minus 4. So multiplying these together, first we get 5x to the 3rd minus 4x squared plus 45x minus 36. And that's it. That is now a polynomial with degree 3 in standard form with all my coefficients are integers. So that's 45x minus 36. So for this next one, it says given the function f of x equals x plus 2 over x squared plus 6x plus 8, write the domain in interval notation. So here our domain is, first important to think about our restrictions. And where our restrictions are going to be is whenever the bottom of the fraction equals 0. So if I can just figure out when the bottom of the fraction, so this part equals 0, I can just skip over those numbers. So let's go ahead, let's try and factor that. Well, we need a number that multiplies to 8 and adds to be 6. So multiples of 8 are 1 and 8. That doesn't work. 2 and 4, that works. 2 plus 4 is 6. 2 times 4 is 8. Now it's really tempting here to say x plus 2, to want to cancel these. But the thing is, when we're looking at our domain, we don't want to just cancel those right off the bat. We want to try and make sure that, like, for domain restrictions, we can only cancel them whenever that is not equal to 0. So in the case that, like, x is negative 2 in this case, we can't cancel these. So our restrictions are x cannot be negative 2 and minus 4. Even though I could cancel out, we're not allowed to do that in case, it's negative 2. Because then it will be dividing by 0. We'll be dividing by 0. So now we need to write an interval notation. So we can do negative infinity works. We'll do every single number all the way up to negative 4. We'll do a union. This is the part that most people will forget. We can go in between our two restrictions, union, and then minus 2 and above. So that is our domain interval notation. Minus infinity, minus 4, union, never forget about the middle one, union, minus 2, and above. So for this next one, it wants us to find the vertical asymptotes. Well, those are going to be when the bottom equals 0. When the bottom equals 0 and it doesn't cancel something on the top. That's when we're going to have a vertical asymptote. So for the most part, you're going to see it usually as just when the bottom equals 0. That's where they are. But we also got to make sure that if there is like something on top, we don't want them to factor. We don't want them to cancel out, because if they cancel out, then you'll get like your graph. So there's, say this is where like one of them are. You'll have a hole, but you won't have an asymptote. So you won't be able to include that spot in your domain. But like in the previous one, we can include in our domain, but we won't have an asymptote there. And that's important to know. So on this first one, we have 3 over x squared minus 3x minus 18. Well, let's go ahead and we'll factor the bottom. So that should be x minus 6, x plus 3. Minus 6 times 3 is minus 18. Minus 6 plus 3 is minus 3. So it means that we'll have an asymptote at x equals 6 and x equals minus 3. And because it's just a 3 on top, neither of these factor. So now for the bottom, we're going to set this one, we'll say x minus 5 over x squared plus 16. We'll take our bottom part, we'll set it equal to 0, equals 0. So we'll say x squared equals minus 16. We get x is going to equal plus or minus 4i, because we're going to take the square root of both sides. And here's the thing. Because they're imaginary, that means that we don't have to worry about these being undefined there, because they're imaginary numbers, right? So we're going to say it has no vertical asymptotes. Okay, bring this one down here. So we have x plus 2 over x squared minus x minus 6. Let's go ahead and factor that. So it's going to be x plus 2 over x minus 3 times x plus 2. So we're going to be undefined or our domain's not going to include 3, and it won't include minus 2. But these will cancel out. So while we can't include these in our domain, when we list our vertical asymptotes, we're only going to focus on this one. So our vertical asymptote is just going to be x equals 3. Well, we only have one because this one will cancel out. But again, when we look at domain, that's not going to be the case. Just when we look at vertical asymptotes, then we'll cancel them out. Okay, so now we're going to figure out where the horizontal asymptotes are. Well, we're going to have a horizontal asymptote. To figure out if we'll have one or not, we're going to have to look at the degrees. So I'll kind of make a flow chart. We're going to have, I'll say, we have degree top, which is going to be our base power of x, and degree bottom is that. So I'll say if degree top is bigger than bottom, then we have none. If, I'll just say top and bottom, but I mean their degree, then we divide leading coefficients, and I'll explain that one when we get to it, because we're going to see one of each of these. And if top is less than the bottom one has a bigger degree. It's always y equals 0. So I'm going to kind of use that. So in this case, our degree on the top is 3, our degree on the bottom is 2. So because the top one is bigger than the bottom one, we'll have no horizontal asymptote. For the next one, our degree on top is 0 because we don't have any x's. Degree on bottom is 2. So because the degree on bottom is bigger than the degree on top, we'll say it's y equals 0. We can always just jump to that. And this one, the degree on top is a 2. Degree on bottom is also a 2. So we'll divide leading coefficients. So we'll look at the number in front of the x squareds. We'll do that. So it's going to be y equals 2 over 3. And now we're done. Okay, so now for the final one of this page. For the following functions, determine if a slant asymptote exists. If a slant does exist, find it. Show all work. So this is going to be kind of similar to horizontal. It exists if the degree of the top is 1 plus the degree of the bottom. So for the top one, right, degree of the top is 3. Degree of the bottom will only have it's going to be 1 plus our bottom. There's an imaginary one that, not imaginary. There's a secret, invisible one there. And so the question is 3 equal to 2? Does not, so there is none. So the first one is no slant asymptote. Okay, now let's look at the next one. Degree of the top is 3. 1 plus degree of our bottom is 2. 3 equals 3. So we will have a slant asymptote. Now to find it, what we're going to do is we'll do long division, and we'll just ignore our remainder. So we have 2x cubed. I believe that was a plus 3x squared minus 5x plus 2. So when I do long division, I'm going to look at this first thing. What do I need to multiply x squared by to get a 2x cubed? Well, I need a 2, and I need an extra x. So I'll subtract. I'll distribute that onto both. So 2x cubed, and then just a minus 10x. I'm going to put it over here so I don't accidentally combine it with the x squareds. Because in this case, we don't have an x squared. So whenever I go ahead and subtract these, 2x cubed minus 2x cubed is 0. 3x cubed minus nothing is 3x squared. Minus 5x minus, sorry, I'm trying to underline it. I don't want to, minus negative 10. So minus minus becomes a plus. So minus 5x plus 10x is going to be plus 5x. And then this plus 2 will just carry down. So now, what do I need to multiply by x squared by to get to 3x? well, it's just going to be 3 because 3x squared minus, sorry, I'll do minus 15. I'll erase that little mark right there. And when I subtract these, those cancel. I just get a 5x. And then minus 15 is going to become a plus 15, so plus 17. Our remainder doesn't really matter. Our slant asymptote is going to be y equals that, whatever we got on the top. And we're stopping because x squared is bigger than x. So our asymptote is going to be y equals 2x plus 3. In the first one, again, had no slant asymptote. And that's it for the page. Okay, so for this first one, we have find the nonlinear asymptote of the following function. So it's going to be pretty similar to slant asymptote. The only difference is instead of like the degrees just being off by 1, they're going to be off by a little bit more. So I'll go ahead and I'll start. So I'll put minus 2x to the 4 plus 8x squared plus 10x minus 8. We're dividing by x squared minus x plus 2. So what do we need to multiply by x squared times what gives us negative 2x to the 4th? Well, we need a minus 2, and we need an x squared. So we'll subtract minus 2x to the 4th. And then minus 2x squared times minus x is going to be plus 2x to the 3rd, which we don't have. So I'm going to erase this part, rewrite it. I'll put a 0x to the 3rd because I don't want to mess that up. I don't want to, subtract from the wrong thing. And then minus 2x squared times plus 2x is going to be a minus 4x squared. So now when we subtract this, minus 2x to the 4th minus 2x to the 4th, those should cancel. We kind of choose it so they will. 0 minus 2x to the 3rd is going to be just a minus 2x to the 3rd. 8 minus 4x squared is going to become 8 plus 4x squared, which is going to be plus 12x squared. I'll bring everything else down. So now what do we need to multiply x squared by to get to minus 2x to the 3rd? Well, we need another minus 2, and we need an x. So minus 2x cubed plus 2x squared minus 4x. So when we subtract these will again cancel. 12 minus 2x squared is going to be 10x squared. 10 minus 4 is become 10 plus 4, so we get plus 14x. Then we bring down a minus 8. And so now, what do we multiply x squared by to get to 10x squared? It's going to be 10 squared minus 10x plus 20. These cancel. We'll get 24x, and we'll get minus 28. But our remainder doesn't matter. Our answer will just be this. So y equals minus 2x squared minus 2x plus 10. Now, for our next one, it's going to be the pretty similar process. So I'll say x squared plus, I put a 0x so I don't forget about it. I don't want to get my powers mixed up. I will have 2x to the 4th minus 3x to the 3rd minus x squared plus 10x plus minus 5. So what do we multiply x squared by to get to 2x to the 4th? Well, we need a 2 and an x squared. So we'll subtract 2x to the 4th plus 0, x to the 3rds, and then plus 8x squareds. 2 minus 2 is going to cancel. Minus 3 minus nothing. We'll just bring that down. Minus x squared minus 8x squared is going to be minus 9x squared. And then we can just carry everything else down. So next, what do we need to multiply x squared by to get to minus 3x cubed? Well, it's going to be minus 3x. Minus 3x cubed plus 0x squared minus 12x. When we go ahead and combine these, minus 3x minus 3x minus 3x cubed plus 3x squared, those cancel. Minus 9 minus nothing. 10 plus 10 minus 12x will become 10 plus 12x, so 22x minus 5. So to continue on, if my pen will work, and it might have died, so give me 1 second. Sorry about that. So to continue on, now it's, what do we need to multiply x squared by to get to minus 9x squared? And that's going to be minus 9. And then plus 0x minus 36. And when we put those together, we'll get 22x. And we'll get, plus 31. But we don't really care about the remainder because our answer is going to be stuff from the top. So we get 2x squared minus 3x minus 9. Okay. So for the next one, we need to solve the equation in the polynomial inequalities. So the first one is just x squared plus 7x plus 10 equals 0. Well, that one, we've done problems like this before. You could use the quadratic formula, or this one factors. So you get x equals minus 2 and minus 5. That one's fairly straightforward. So, and if we're going to put this as like a, I don't know, like set notation, we'll put a little curly brace, and we'll do minus 2, comma, minus 5. Or let's do minus 5 first, go from low to high. And that just means like the list of solutions are minus 5, comma, minus 2. Now, to do this next one, B, now it's going to be x squared plus 7x plus 10 is greater than or equal to 0. Well, I'll factor it again. But this greater than or equal to thing is going to be kind of weird. So we just can't, previously we just found when it was 0. But now we're going to figure out, well, what about in between? Is that going to be bigger than 0 or is it going to be less than 0? So what I'll do, I'll put a little number line, I'll put minus 5, I'll put minus 2. And I'll check somewhere in each of these intervals. And I'll say, is it bigger than 0 there, or is it less than 0? And I'm going to take the ones that are bigger than 0. So I'll go ahead and I will try something on each of these intervals. I'm going to start with 0 over here, because 0 is bigger than negative 2. If I do 0 squared plus 7 times 0 plus 10, that is just going to be plus 10. 0 squared is 0, 7 times 0 is 0, so we should get 10. And that is bigger than 0. So we're going to include that section. Something between minus 2 and minus 5, I'll do minus 3. So minus 3 squared plus 7 times minus 3 plus 10. We get 9 minus 21 plus 10, which is negative 2, which is not bigger than 0. So that's not true. Not true. So I'll try minus 6. So we'll do minus 6 squared plus 7 times minus 6 plus 10. So we get 36 minus 42 plus 10. That 36 plus 10 is 46 minus 42, which is 4, which is greater than or equal to 0. That works. So we're going to include all of this and all of that. And then because we can also equal 0, we can include both the spots that we previously found equal 0. So we're going to say it is from minus infinity to minus 5, bracket, because we can't be at minus 5, union minus 2 to infinity. And there's that one. Okay, so now we're going to go on to part C. It's going to be pretty much this exact same question, but this time it's going to be less than or equal to. So once again, I'm just going to copy a lot of the work I just did. Plus 10 is less than or equal to, less than or equal to. So now I'm going to set up the same number line. And again, I can even check the same points. 0, minus 3, and I did minus 6. And I can even, I can plug these all in again. And the big difference is now I want it to be less than 0. So here I get 10, but 10 is That's not true, so I'm not going to include this section this time. When I do 3, I got minus 2, which is in fact less than or equal to 0. So this time we're going to include this middle section. And when we did this one, we did minus 6 squared plus 7 times minus 6 plus 10, which we got was positive 4. And, sorry, it's that way. And that's not true. So we only include this middle section. And because we can't include 0, we'll include the 5 and the minus 2 with it. Now for the part D, well, this one is the exact same question as this, except for this one, we now can no longer include 0. So I'm just going to use my same intervals, but now I'll put parentheses instead of a bracket because I can't include those values. Now moving on to 12, solve the rational inequality. Well, we have x plus 1 over x minus 5 greater than or equal to 0. So what I'm going to do is I'm going to set up my number line, and I'm going to check a couple spots. I'll set the bottom equal to 0, and we get x equals 5. So I'll check at 5. And I'll set the top equal to 0, x plus 1 equals 0, x equals minus 1. Note that I can include minus 1 because you can have 0 divided by something, and that works. But I will not be able to include my 5 because something divided by 0, that's impossible to do. So whatever my intervals are, I cannot include 5. Just a note before I do anything else. So let's go ahead and pick some things to plug in. I'll plug in 0, let's say like minus 2, and I'll plug in 6. So I'll do minus 2 first. So we have minus 2 plus 1 over minus 2 minus 5. And we need to see if that's true. Well, we get negative 1 over negative 7, which is the same thing as 1 over 7. Cancel out the negatives. And that is true. So that we are going to include that section. And if we want to check if we can include negative 1, well, negative 1 plus 1 over negative 1 minus 5, you get 0 over minus 6, which is the same thing as 0. And 0 is greater than or equal to 0, so we can't include negative 1. That's one way we can check. Now let's plug in 0. So we'll have 1 over minus 5, because 0 plus 1 is 1. 0 minus 5 is 5. And that's a negative 1/5. That is not true. That is a negative number. So we're not going to include that section. Okay, well, what about 6? So we can do 6. Whoa. I'll do that. So I'm going to go ahead and do... sorry, I lost my train of thought there. 6 plus 1 over 6 minus 5. Well, 6 plus 1 is 7. 6 minus 5 is 1, so it's just 7. And that is greater than or equal to 0. So this section will work. So when I go ahead and I'm going to put my interval, I can go from minus infinity to minus 1. And I'm going to include it because I can't plug in negative 1. I'll get out an answer, which is 0. And 0 is greater than or equal to 0. Then I'll do a union. I'm going to do 5 with a parenthesis. And if you want to check, we do 5 plus 1 over 5 minus 5, which is 6 over 0. And I don't know. It's undefined, so we can't include it. So 5, and then that's going to go to infinity. And that's the answer for that one. Okay, so for 13, for this first one, I'm going to go ahead and I'm going to distribute my x, and I'll move that over because I'm going to try to compare it to 0. I like comparing things to 0. That's pretty easy. So x squared minus 3x is greater than or equal to 18. And I'll subtract the 18 over. X squared minus 3x minus 18 is greater than or equal to 0. And this will factor x minus 6, x plus 3, greater than or equal to 0. So I'll put my number line. I'll have minus 3, and I'll have 6. And because there's no divided by like any x thing, I can include both of these because it's greater than or equal to 0. So being 0 is okay, and I'm not dividing by something. So, there is no divide by 0 concern. So I'll check something in the middle of these. I'll do 0, I'll do -4, and I'll do 7. So if I plug in -4 in, -4, I'm going to go ahead and plug it into this one, because that might be a little easier. So -4 -6 times -4 plus 3. -4 -6 is -10. -4 plus 3 is -1. 10 times -10 times -1 is +10. And that is true, so that works. We'll include that section. If I include 0, 0 -6 times 0 plus 3, that's -6 times 3, which is -18, which is not true. So we cannot include this middle section. So when I try with the 7, 7 -6 times 7 plus 3. 7 -6 is 1 times 7 plus 3 is 10. And 10 is greater than or equal to 0. So that works. We will include that. So our solution to our inequalities are going to be -infinity, comma, -3. And we're going to include -3 because if we plug in -3, that will work. That is fine. If we plug -3 into this one, you'll get out 0, but 0 counts. So we'll include it, union, and it will say 6, comma, infinity. And that's the answer for that part. Okay, for the next one, we'll do x squared minus 2x plus 4 is less than or equal to 3. I'll move the 3 over, so we get x squared minus 2x plus 1 is less than or equal to 0. Well, I can go ahead, and this actually will factor to x minus 1 squared less than or equal to 0. So when I set up my number line, I'm going to have just 1. And because of how like a square graph looks, it's either going to look like shoot off like both that way or shoot off both that way. So I'll look at 1. If I plug in 1, that works. So 1 minus 1 squared is 0 squared, which is 0, and that is less than or equal to 0, so 1 will work. I'll plug in 1 on each side. Plug in 0, I'll plug in 2. 0 minus 1 squared is -1 squared, which is +1, and that's not true. So that side's not going to work. If I try 2, 2 minus 1 squared is 1 squared, which is just 1, which is not less than or equal to 0, so that's not true. So that side's not going to work. So the only thing that we had was just the 1. And so that is the solution to that inequality. The only number that is true for is 1. There is nothing else. So I'm going to put in this squiggly bracket to say just the 1 with nothing else included. So going on to part C, we have 8 over 3x minus 4 is less than or equal to 1. Now, a common mistake I will see people make is I will see them try and multiply over. We're not going to multiply it by stuff involving x's in this case on both sides because it's going to make our inequality sign kind of funky. So instead, we can only add and subtract. So I'll bring this 1 over. So let's say 8 over 3x minus 4 minus 1 has to be less than or equal to 0. And then for this 1, I'll multiply by 3x minus 4 over 3x minus 4 so that we have a common denominator. We can combine these fractions. I can multiply here because 3x minus 4 over 3x minus 4 that cancels itself. I'm not doing anything to both sides. I'm just writing it in a way that will allow me to add. So when I go ahead and I subtract these, 8 minus 3x minus 4, so we'll get a minus 3x on top. Then 8 minus 4 is going to become 8 plus 4, which is going to be 12. And now we're going to figure out what our number line is going to be, we're going to check when the bottom part equals 0, which we're going to get is 3x equals 4. X is going to equal 4 thirds. And when the top equals 0, so minus 3x plus 12 equals 0. Minus 3x equals minus 12. X would be positive 4. And I'm going to note once again that we can, this one we could potentially include in our intervals, because when the top equals 0, that's fine, but we cannot at all ever include the 4 thirds, because that's when the bottom is 0. I'll go ahead and I'll erase it. I'll go ahead and put it like way up here. So we have 4 thirds and 4. So I'll plug in something below 4 thirds, which I always like to plug in 0 because it's usually pretty easy. So I'll try 0. Plug in something in the middle. 4 thirds is a little bit more than 1, so I'm going to go with 2, because 2 is in between 4 thirds and 4. And I'll try 5. And I'll plug it into this one, and I'll see if that is true. If we will get something that's less than 0. So when I plug in 1, you get minus 3 times, sorry. When I plug in 0, I meant to say. Which is just going to get us 0 plus 12, 0 minus 4, and that gets you minus 3. And that is true. So we can include below 4 thirds. Let's see if we can include 2. So we do minus 3 times 2 plus 12 over 3 times 2 minus 4. Well, that's going to get us minus 6 plus 12 over 6 minus 4, which is going to be positive 6 over positive 2, which is just 3. That's not true. 3 is not less than 0, so we're not going to include the middle section. Let's try 5. I'll go below. So minus 3 times 5 plus 12 over 3 times 5 minus 4. Well, minus 3 times 5 is minus 15 plus 12 over 15 minus 4. That'll give us minus 3 over 11. And that is less than or equal to 0. That works. So we're going to include that. So our interval is going to be from negative infinity to 4 thirds. And we're not going to include 4 thirds because that's going to make the bottom of the fraction equal to 0. It comes from the bottom. Like that's where we found that. So we can't have that happen. And then union. We can include the 4, because we include the 4, that will work, to infinity. Okay, now for our last one, we have 3 over x minus 2. This is minus 2 over x. So I'm going to add this over. So we have 3 over x minus 2 plus 2 over x less than 0. And now I want to make this into one fraction, so I'll multiply this left one by x over x, this right one by x minus 2 over x minus 2. So we have 3x over x times x minus 2 plus 2x minus 2 over x times x minus 2. I can distribute that and make this into 2x minus 4. And now when I add these together, we get 5x minus 4 over x times x minus 2 is going to be less than 0. So I'll set my bottom equal to 0. So I'll get x equals 0 and x equals 2 from saying those equal to 0. And I'll set my top equal to 0. So 5x minus 4 is 0. So 5x would be 4. X would be 4/5. So when I set my interval, I'll have 0, 4 over 5, 2. Also, notice how I'm no longer able to be equal to 0, just strictly less than 0. That means I cannot include any of these in my interval. So just wanted to put that out there. So I'll check. I'll do minus 1. Between 0 and 4/5, that's kind of weird. I want to do 1/2. between 4/5 and 2, I'll do 1. And between 2 and on, I'll do 3. So, starting on this, let's try -1. I'll plug it into this thing. So, 5 times -1 minus 4 over -1 times -1 minus 2. It's going to be -5 minus 4 over -1 times -3, which is -9 over -1 times -3 is 3, which is -3. And that being less than 0, that is true, so that's going to work. Now we'll try 1/2. This one's going to be the weirdest one. 1/2 times 1/2 minus 2. So we'll get 5. We can treat this as 0.5 just for the sake, so we'll get 2.5 minus 4 over 0.5 times -1.5. On top, we'll get a -1.5. On bottom, we'll get a -0.75. And that gives us, if we put that in a calculator, we'll actually just get 2 out of here, a +2. And that is not true. So we're not going to include that in our interval. Now if we try 1, 5 times +1 minus 4 over 1 times 1 minus 2. Well, we'll get 5 minus 4 over 1 times -1. So we get 1 over -1, which is just -1, and that is less than 0. That works, so we'll include 4/5 to 2. And now for 3, I'll plug it in like down here. 5 times 3 minus 4 over 3 times 3 minus 2. That gives us 15 minus 4 over 3 times 1. 15 minus 4 is 11. 3 times 1 is 3. And that is not true. That's bigger than 0. So we cannot include that one. So in our final interval, it's going to be -infinity all the way up to 0. And we're going to put a union. It will say it's our 4/5 to our 2. We're not going to include either of those because we cannot equal 0 in this case. And in the case of the 2, that's when the bottom equals 0. So we weren't going to include that no matter what. And then that's it. And that's all for that one. Okay, now for this next one, we need to find the x and y intercepts of the following functions. So to find our y-intercept, we just plug in 0 for x. So I'll do my y-intercept. I'll put 0 in for my x. So we'll get 3 times -5 over 4 times -3, which is going to be -15 over -12. Negatives cancel, and we can divide each of these by 3, so we get 5 over 4. So my y-intercept, we'll say is 0, 5 over 4. For my x-intercept, what we're going to do is we're going to take the top, we'll set that equal to 0. So we'll figure out x plus 3 times x minus 5 equals 0. And you'll find that you'll get x equals -3, x equals 5. So my x-intercepts are 5, 0, and -3, 0. And that's it for part A on that one. So I'll go and I'll rewrite this. Okay. And now for G, well, my y-intercept is I plug in 0, so I'll get 2, 0 plus 2 is 2, over 0 squared is 0, -0 is 0, plus 3 is just 3. So for my y, it'll be 0, 2 over 3. And now for my x, I'm going to set the top part equal to 0, which you get x equals -2. So my x-intercept is going to be -2, 0. And that is it for that one. So for the last one on this page, determine the point, if any, where the graph of the function crosses the horizontal asymptote of the function. Well, first we have to figure out what the asymptote is. Well, we look at our degrees. Because the top is the same as the bottom, we take the -4 and we divide it by what's in front of the x squared in the bottom, which in this case there is nothing, so we say 1. So -4. So our Horizontal asymptote is y equals -4. So to figure out where it crosses, we'll put -4 is going to equal minus 4x squared plus 5x minus 1 over x squared plus 2. And we'll try and solve for x. So I'll multiply that over. So minus 4 x squared plus 2 equals minus 4 x squared plus 5x minus 1. Distribute the minus 4x squared minus 8 equals minus 4x squared plus 5x minus 1. I'll add 4x squared to each side, so we get minus x equals 5x, sorry, minus 8 equals 5x minus 1. I'll add the 1 over, so we get minus 7 equals 5x. That means x equals minus 7 over 5. The only time that I have to worry about if it doesn't cross the horizontal asymptote is if the answer I get, if I plug it in, if I get something that's undefined. So in this case, the bottom of our fraction is x squared plus 2. To check where it'd be undefined, we'd solve for x. We set it equal to 0, we solve. And what we get is we get a square root involving a negative. So that means the only place it's undefined will be imaginary numbers. So because we don't have to worry about it not working. So in this case, this will work. So where is it going to cross? The point is going to be, we have our x coordinate. This will have to be our y coordinate because it's crossing there. So it's going to be at negative 7 over 5, comma, minus 4. And that's our final answer.
All right, so now let's look at number 16. It's asking us to graph the rational function f of x equals 2x squared minus 2x divided by x squared minus 3x minus 18 by hand and fill in all of these blanks. Okay, so let's first start with the domain of this function. Now, to look at the domain, we need to find any domain restrictions. So I think we should do this by factoring the bottom and top of our fraction here. And so looking at this, we have 2x squared minus 2x, and this can be factored into, let's see, 2x times x minus 2. So that's the top, and then the bottom of this, x squared minus 3x minus 18. This becomes x minus 6 times x plus 3. Okay, so let me just write out our function after we factored it. We have f of x equals 2x times x minus 2 divided by x minus 6 times x plus 3. Okay, and so now when we're looking at domain restrictions, we need to consider taking the square root of the negative number and dividing by 0. And so since there aren't any square roots in this function, we only need to see where we might divide by 0. And so to do so, we should look when our denominator is equal to 0. And this is our denominator. And so from this, we can split this up into two equations. X minus 6 equals 0 and x plus 3 equals 0. And we find that x can equal 6 and negative 3. But actually, we don't want x to equal either of those things because then we divide by 0. So let's now look at our domain. Because x can't equal these values, but there seems to be no other issues, we'll go all the way from negative infinity up to negative 3. And then we have a break, so we put a union. From negative 3 to 6. And then we have another break at 6, so we'll do another union and then go from 6 all the way to positive infinity. Okay, so that's our domain. Next, we need to know what our y-intercept is. So our y-intercept occurs when our x is equal to 0. And so if we look back at our original function up top here, really we just need to find what f of 0 is. take that away because it covered it up. But f of 0 equals 2 times 0 squared minus 2 times 0 divided by 0 squared minus 3 times 0 minus 18. And we see that we end up having 0 on top and negative 18 on bottom, which is just 0. So because of that, our y-intercept happens at the point 0, 0. Okay. Next, for our x-intercept, we need to see here, also, I just caught a mistake from earlier. So I'm going to go back here to where I was doing this factoring work, and that I turned 2x squared minus 2x into 2x times x minus 2. That's not actually right. Let's see, let me fix that. Should be 2x times x minus 1. My apologies. So I'll also fix that down here. Okay, but that shouldn't affect anything as long as I fixed it there. So the x-intercept happens when the numerator is equal to 0, and I know that because it's when the whole fraction is equal to 0, and we can only have the numerator of a fraction equal to 0, kind of like what we were talking about with our domain. And so I'm going to take the top of this fraction. I'm actually going to take the factored form here because that's easier to work with, and I'm going to set it equal to 0. So this is 2x times x minus 1 equals 0. So I'm doing this again to find the x-intercepts. So I'm setting my function value equal to 0 and solving. Okay, and so we split this up into 2. So we get 2x equals 0 and x minus 1 equals 0. And so from this we get x equals 0 or x equals 1. And so these are our two x-intercepts. Okay, so we have one at the point 0, 0, and the other one is at 1, 0. Okay, now we're going to look at the vertical asymptotes next. And in a way, we've already done this work, all right, because this is where we have those breaks in our domain because x can't equal those values. And so we have our two vertical asymptotes at x equals 6. That's a vertical line, and so is x equals negative 3. Those are our two vertical asymptotes. Next, we need to look at our horizontal asymptote, okay? And so we get this by examining what our function goes to as x goes to positive or negative infinity, okay? And so I want to looking at that, we see that with our function, we have a 2x squared on top and an x squared on bottom. And as our x gets bigger and bigger, whether it's getting more negative or more positive, those x squared terms are going to have the most impact. And since it's being squared, the negative infinity doesn't matter. And so you see we have 2 times a big number on top divided by a big number on bottom. So we end up with just 2. So let me kind of write that out. So we have that as x approaches positive or negative infinity, f of x approaches 2. Okay, so therefore our horizontal asymptote is at y equals 2. Okay, and so what we want to do next is see if there is any point at which the graph actually crosses that horizontal asymptote. And so let's see here. All right, so what we're going to do to find where that graph crosses the horizontal asymptote is I'm going to set the whole equation equal to our value of 2. So very similar to what we did with finding the x-intercepts where we set it equal to 0, this time we're going to set it equal to 2. And so I'll kind of keep going through this while I erase that earlier, we just had to set the numerator equal to 0 because we knew that nothing on the denominator could make it equal to 0. But now we need to consider the whole function for this, okay? So I'm going to consider 2x squared minus 2x divided by x squared minus 3x minus 18 equaling 2, okay? So first I'm going to multiply the denominator both sides, and so we'll get 2x squared minus 2x equals, I'm going to go ahead and distribute this 2. So 2 times x squared is 2x squared, 2 times negative 3x is negative 6x, and 2 times negative 18 is negative 36. Okay? So now I'm going to solve this. First thing I see is that we can subtract 2x squared from both sides. That's actually going to cancel it out because it's already on both sides. So after doing so, we have negative 2x equals negative 6x minus 36. Next, I'm going to add 6x to both sides, and I'll get 4x equals negative 36. Dividing both sides by 4, I end up with x equals negative 9. So therefore, the function value when x is negative 9 is 2, which is where our horizontal asymptote is. So therefore, our graph will cross our horizontal asymptote at the point negative 9, 2. Okay? And lastly, our slanted asymptote, this last thing before we get to additional points for graphing, we don't have one. And this is actually because our numerator and denominator have the same degree. And so since they have the same degree, there's no slant asymptote. So I'll just write none. Okay, so on to additional points. What I'm thinking here is that we just need to kind of evenly space these out and have them close to and around where our asymptotes are, just to kind of help us see what the behavior of the function is. Okay, so I'm going to pick some x values here. Start at negative 8, negative 6, negative 4, negative 2, 3, 7, and 9. Okay, and I went ahead and plugged these into my calculator, and I know that this is 2.06, so that's the function value when x is negative 8. This is 2.33. This is 4. This is negative 1.5. This is negative 0.67. This is 8.4, and this is 4. Okay, so again, to get these, you just take your x value, plug it into your function in your calculator, and you'll get these values like I did. Okay, so next what I want to do, we have these additional points as well as all of the other points we kind of established here, like our y and x intercepts and where the graph crosses the horizontal asymptote. I want to start by drawing where those asymptotes are. Okay, so this might get a little messy, but just bear with me here. So I'm going to start with the horizontal asymptote, which is at y equals 2. Okay, like I said, getting a little messy, but we'll just pretend that's a straight line. We have vertical asymptotes at x equals negative 3, which is here. That one's a little better. And also at x equals 6. Okay, so that's where those are. Those are our vertical and horizontal asymptotes. I'm going to go ahead and label those just to be clear about what those are. X equals 6 and y equals 2. Okay, I'm going to switch to a different color, and I'm going to plot some points. Okay, so first we have a y-intercept and x-intercept at 0, 0. So I'll just mark that here. And then we have another x-intercept at 1, 0. So we have that going on right there. And then, let's see, we have a point at negative 9, 2. So that's right here. And we have our additional points, so I'll go through those just real quick. So negative 8, and then about 0.06, so just above that line. And then -6, 2.33, go about there. -4, 4, got that. -2 and -1.5, so about there. And then 3 and -0.67, so right there, close to -1. 7, we're at 8.4, at that point. And then at 9, we're at 4, okay? So based off of this, the shape of these functions should be kind of clear. So I'll do my best to sketch these out. So got this line that goes like this. I'm gonna retrace that, okay? So like that, and then our middle one here will have this sort of behavior going on. Okay. And then lastly, we have this up here. Okay. So I would encourage you, after you've finished graphing this, to go ahead and plug it into your graphing function on your calculator to see if this matches what we've drawn here.